All right, chemically driven processes. One is oxyacetylene, but I don't have time to discuss it, but in this case, you have a flame that is made chemically. But I wanted to mention this other one, thermite, because although oxyacetylene is somewhat obsolete, thermite is still being used. And the point I want to bring in this conversation is that we are talking now, we're going back to fusion, but in this case, the energy for fusion comes from chemical reactions. It doesn't come from an arc, doesn't come from resistance, doesn't come from a beam, and there is no mechanical energy here, but it's just chemical energy in place. And in thermite, what you have is a chemical reaction, and I'll go over this one quickly, but you have iron oxide, and then you have pure aluminum. And what happens is the iron oxide is a weak oxide that is easy to break. The aluminum oxide is a very strong oxide. Aluminum is very reactive and wants to steal the oxygen from pretty much everything, including the iron. So if I mix iron oxide with pure aluminum powder, and then I give it heat such that the reaction starts going, what's going to happen is this aluminum is going to steal the oxygen from the iron oxide and create alumina. And then the iron will be by itself and will be so hot that it is molten down, right? And this is a very exothermic reaction. And you can do the same with copper. And in this case, imagine you wanted to join this rebar, these two pieces of rebar. You have this crucible in which you make the reaction happen. And when the reaction happens, the molten steel at very high temperatures come in and remelt part of the rebar, and they becomes joined. This is the way you weld train tracks. So let me show you a video of something very similar to thermite, which in this case, it was making, this is molten aluminum in which we put titanium and carbon to make titanium carbide in the reaction. And you're gonna see how it is exothermic. Oops, here. So that was a pellet of titanium mixed with graphite. And the yellow is molten aluminum. There you go. Then it ignited, and the titanium reacting with the carbon and generated all that heat. So these are all like cousins of the thermite process that is used for welding railroad tracks. That was done in the foundry I ran when I was a professor in Colorado. All right. So we're a minute behind, but I wanted to share that with you. We can stop here, and I'll see you again on Tuesday. On Tuesday, instead of the seminar, we're going to have our